the last thing that we're going to cover in this chapter is looking at area problems. So something where we might have a rectangle, which let's say is a pool. And then we might have a deck around this pool. And our goal is to figure out what the area of that deck is. And we're going to use, what that means is we're going to use the entire chapter, everything we've been talking about, from exponent rules, combining like terms. We're going to be using literal equations and solving equations to figure out area problems like this. So for example, we might have a situation like this where Sebastian made a rectangular fish pond surrounded by a brick walk that is 2 meters wide. Okay, so let's just remember that one of our equation or word problem skills is to take each of these things bit by bit and break it or translate it into parts. So this first sentence right here, I'm going to represent this by a picture. I'm not even going to start with an equation or an expression yet. I'm just going to start it with a picture. So this picture then, I'm going to say I've got this rectangular pond. Let's make that a little bit bigger. Make it a little bit bigger, right? So we're going to say we've got a rectangular pond here. And it's surrounded by a brick walk that's 2 meters wide. So what that means is right here, I've got 2 meters. From there to there is 2 meters. From here to here is 2 meters. And then on the top and the bottom also. So I'm coming out 2 meters here. And that's where they're joining up. And that's where they're joining up. And then also here, I've got 2 meters. So let's just draw this as our pond, right? And then all the way around, we've got 2 meters added to each dimension of this pond. And this entire picture represents that first sentence right there. Now, we see that he had enough bricks for the area of the walk to be 76 meters squared. So I'm just going to denote that right here. The area of the sidewalk is 76 meters squared. And I know that the area of a rectangle is length times width. So I'm just going to note that up here. The area of a rectangle is length times width. Okay, now what I want to do is read this last sentence. So find the dimensions of the pond if it is twice as long as the width. Now here, what this means is I'm looking at pond specifically. So the pond is just this blue part inside, and it says the pond if it is twice as long as it is wide. So I'm going to remember that length is here, width is there, and twice as long. That means that the length is actually 2W right there. That's what the width is. So now what I'm going to do is I'm going to think to myself, my goal is to find the dimensions of the pond. And the information that they give me is that I know the area of this bit out here. I know how wide the sidewalk is, and I have an expression for how the length and the width in here are related. Okay, so if I were to find just the area of this part right there, then that would mean that I have, again, length times width is area of a rectangle. So in here, this inner rectangle is going to be 2w times w, right? So taking the length and the width and putting it right there, I've got 2w times w. And I know that the outer part right here, this area, is 76 meters squared for the brick walk there. So what I'm going to do is I'm going to see what the dimensions of this entire thing is here. I'm going to take this big rectangle and subtract out this little rectangle, and that'll give me what is left on this border. So this is a pattern, this is a type of problem and a pattern that you're going to see over and over. You'll see it in your problem-solving journal, you'll see it throughout this year, you'll see it throughout geometry. And really it's something that you'll continue to look at throughout your math career. So taking a big area, subtracting out a little area, gives you this part that's left. Okay, so I've just taken the diagram over to the side to give us a little bit more space here. So let's see, what I've got is, I want to take the area of this big, make it just a little bit bigger. I've got to think through, what is the area of the big thing? Well, in order to find that, I've got to come up with, what is the entire length right here? Well, that length is going to be this length right here in blue, which we know is 2w. And then we're also going to notice that on this side, we've got 2 more meters. And on this side, we've got 2 more meters. So this entire length right here is going to be equal to 2w plus 4. And we're going to do the same thing for the width right here. So I'm going to notice that up and down right here, I've got a width of w right there, and then I've also got 2 meters on top, and I've got 2 meters on the bottom. So this whole thing right here is going to be w plus 4. Okay, so what does that mean? What it means is I have got an expression hidden away. It's a little bit hard to read. We'll pull it out. Hidden away in here. I know what the area in here is 2w times w. And then this big rectangle here is going to be these two things, these two expressions multiplied together. So let's write this whole idea out. I'm going to make this diagram a little smaller. There. Make this smaller. Fit in. Move that up there. Right? And so I'm going to write out all of my thoughts. Okay. So I'm going to remind myself of the goal here. The goal is to find the dimensions of the pond. Find the dimensions of the pond. Ultimate goal. And in order to do that, given the information that we have to take the area of the big rectangle, subtract out the area of the pond, and that's going to give us the area of the walkway, which we know is 76 meters squared. Okay, so now the area of the big thing, that's what we just figured out right here, the area of the big part. So I'm gonna simplify that. Let's see. I'm gonna say area of the big is equal to w plus 4 times 2w plus 4. All right. I'm going to make this simpler before I plug it into this big, huge expression. I'm going to use my polynomial multiplication skills to figure this out. So I'm going to take the first w, I'm going to say 2w times 2w plus 4, and then I'm going to have a 4 times 2w plus 4. You might also use the lattice method, whichever method you use to multiply two polynomials together. You might also use FOIL. So this is going to then be 2w squared plus 4w plus 8w plus 16. So this is going to simplify to 2w squared plus 12w plus 16. So this whole long expression here, this whole long expression, or this second degree trinomial, just expresses this outer or the bigger rectangle. Now the smaller rectangle we've seen already, that smaller rectangle is 2w times w, which equals 2w squared, right? So that came from this expression that we wrote a while ago, just right in there, the area of that small pool. And that is this right here. So now I've got to take this big polynomial for the big outer rectangle. I'm going to subtract out the smaller polynomial right here, and that's going to give me a 76. So before I worry about solving this entire equation, I'm going to simplify each side. So let's again make all of this work a little bit smaller, give us some more space. Okay, so my equation that's going to solve for the dimensions of the pond is this long thing. I've got 2w squared plus 12w plus 16 minus w squared gives me that 76. So now what I'm going to do is use my combining like terms skills. I'm going to see that I've got 2w and minus 2w there. So when I write it out, I've got 2w squared minus 2w squared, and then nothing that combines with these terms. And then I'm not going to forget that 76 over there. What's nice about this problem is that when I've got 2w minus 2w, that actually becomes 0, right? And so in other words, it just cancels itself, which is pretty nice. So that leaves me with this equation right here, which is something that I can definitely solve. So again, I'm going to make myself a little bit more room. And now we're getting somewhere. We've got 12w plus 16 equals 76, and just subtracting a 16 from both sides. We've got 12w equals 60. I'm going to divide by 12 on both sides, so I get that w is 5. Whew. Okay, I get w is 5. I know my original units were meters, so 5 meters. And now I'm going to go back to the problem and read it one more time. So we've got Sebastian made a rectangular fish pond surrounded by a brick walk that was 2 meters wide. Okay, we used that. He had enough bricks to use for the area of the walk to be 76. So we used that. Find the dimensions of the pond. We've only found one dimension. Okay, if it's twice as long as it is wide. So in here, we accounted for that. We said the w is 5 meters, and the length is 2 times w. So what that means is the length is going to be 10 meters. So the dimensions of the pond are 5 meters by 10 meters.